Hello, everyone. Today, I'd like to talk about normality. So, normality assumption is very important when you run the analysis, such as t-test, and also the correlation and the regression. So, when you don't assure that your continuous variables have the normality violation, and then it's a very disadvantageous to present your result as a valid one. So it's very important to assure your normality of your continuous variable. So for instance, like here, you can see that life satisfaction, self-esteem, depression, and self-perception, those are the typical Likert scale continuous variables. So normally you will use those variables for correlation, regression, also t-test. So if you want to evaluate about the normality, first you have to go. We will treat this time with the life satisfaction. So you will go to the analyze and the descriptive statistics, and then you will go to the explore, and then you will put your variable. For instance, the here life satisfaction here, and then you will do a statistics, and then you will put this descriptive and outliers. That is fine, and then plot will be the histogram instead of sum and leaf, and also the check normality plot. Continue, and then you can do okay. So this will generate the output. You can see their life satisfaction, this variable, and then you will have all the statistical values like a mean and the median and the standard deviation, minimum, maximum, and then also skewness and the kurtosis. So normally the skewness and kurtosis, that is between the minus plus 1.5, that means that its normality is assumed, but it's greater than that. It's a point plus minus 1.5. You have to think about the normality problem. And also extreme values that shows that which one is the extremely dispersed according to the other regular values. For instance, this one here is a 8, and the others are 11, 12, 12, 13. It's not like a big difference, but this one is particularly lower than others. So you can see that. Normality test that shows that it's less than 0.001. And normally, normality test does not give you the satisfactory result. It's very difficult to satisfy. So this one will be just the symbolic, and then if even though there is not significant, yeah, this is a significant. So you need a not significant result, but in general, they are very significant almost all the time. So this will be the last thing you have to consider. That is a normality test. And the histogram, when you see that your graph, and then you can double click, and then you can draw the normality line, and then when you close, that will, you will go back to your output, and then the line is drawn. This doesn't seem to be very much skewed, or the curtosis also it's okay. It's a bit flat, it's a platycurtic, but it's not really the big problem. And this you can verify with your skewness and the curtosis. They are not greater than plus minus 1.5, so it's fine. So and also the QQ plot shows that in the model line, and then those individual scores not very far away from that. So the skewness and kurtosis also is not a big problem. And then finally, you have the outliers here, but they are not like extreme values, because when that is extreme values, you will see the asterisk, but there is no asterisk, just they are a bit lower than the normal lower scores. So for overall, this life satisfaction is not the variable who has the problematic with the normality. We can say that this one satisfies the normality exigence, so it's fine. However, when you go to the your another variable, for instance, like a depression one, we can run the test, analyze, descriptive, and explorer, and then now we take back to the box, and then we take the depression, and then now let's examine about the normality of depression. So you do okay. And now here you can see it's a big number than greater than the plus minus 5, 1.5, sorry. So skewness is okay, but about the kurtosis, that it has some greater than what we can allow. And also the extreme values, you can see that that is the very much different from the other normal scores of the high. So the 50, that is really much greater than the others. So we have to think about this one. And still, normality KS test, it shows the significant. So this is not a good news. Normally, it should be not significant to assume the normality. But as I said, this is very difficult to satisfy this test. Now, your histogram, you can double click and then normality line, and then you can see that that is positively skewed. So much scores are in the lower part, and then you can see the only one score is the extreme score is a 50. So we have to think about this one. How we can remove this score. We have to think about that. And then you can see still that is a problematic, that is too much far away from the line. Okay, and then yeah, now you can see that is extreme score. It's a asterisk. That means it's not only the outside of these two lines, but it's a maximum line. But there is it's too much difference from the maximum line. So we have to think about that. So about this, how you can solve that normality problem because of that outlier. You will see here in the extreme values, not this one, sorry. This is about the depression. Yeah, this one. You will see that extreme values. It's only one thing. It's too much high score is there. That was about the asterisk. So you can see the normal scores started from the 31, 31, 32, and then 37, and then 50. So we can use the missing value option to take out those values from the analysis. So how we can do that? You will go to the your variable view, and that is a depression, and then that is the there is no indication about the value because that is the pure numbers. So you will go here about the missing, okay, missing, and then you click this part, and you will range from it's like about the low is 35, and then high is 50. Those scores will be eliminated, and then that will be considered the missing values. And then when you click the OK, now that asterisk value 50 will be automatically deleted, and even the extreme value of the 37 will not be included in the analysis. So we can manipulate that by missing values to erase the uh, outliers. So let's see what is the result now after that. Analyze descriptive statistics, Explorer, and then same depression, and everything that we already settled that will not change here. So we can leave that, and then okay. And now you can see there are missing values. There are two. That is greater than 35 until 50. They were erased. So now you don't have any more that extreme value of the 50. And then you can see the graph changes. It's not exactly like positively skewed now. So you can see it's more like a normal form. Yeah. And then also the about the still they are a bit deviated from the line, but not like the others, like a very big distance from that. And then also you don't have any more extreme scores. So with this, we can say now this variable is normally distributed. Skewness is normal, is not greater than plus minus 1.5, and this also. So you can see that by discreting your values, extreme values as a missing value, Like that way, you can run the analysis considering the variable now is the normality is assumed. Okay, so this is what I want to suggest. You don't have to delete the person's number, but you can keep them just using the missing value and then just click those values and then you can do analysis while assuming the normality. So I hope this will be helpful for your analysis. Thank you and see you next time. Bye.